Hello everyone, and welcome to AWS in real life. The point of these videos is to give you real-world examples and experience working with AWS. The goal of these videos is to work through real-world scenarios by utilizing services provided by AWS. My hope is that these videos will help you to come up with your own solutions for issues or problems you may come across. With that being said, let's get started. So the point of this video is to help you understand how to use EC2 with user data bootstrap scripts to deploy code packages. So we have a checklist here and the scenario. The scenario is you work for a small tech startup and you are looking to host your web page in AWS. You have a few developers working on your website and they are using a build system to compile and publish code packages to an S3 bucket. Right now, your company is in the beginning stages of its move to AWS. You have been tasked with creating an infrastructure that will be fault tolerant, durable, cost effective, along with providing your company the ability to easily roll out new deployments without downtime to your site. So our goal for this video will be to create a simple web page with infrastructure that is fault tolerant, self-healing, and will permit developers to easily deploy code packages from a highly durable and fault tolerant centralized storage. So the technologies that we will be using for this video, in AWS we're going to be using S3, EC2, and under EC2 we're going to use an EC2 instance, auto scaling with Lifecycle Hooks, launch configurations, load balancers, and instance user data. We are also going to be creating a VPC. We're going to use the AWS CLI command line interface and IAM. And we will also be installing the Apache web server on our instance. So here's the steps that we're going to go through. First, we're going to create a VPC using the Vpc Wizard. We're going to create a second subnet that will route to our internet gateway because that's required for our load balancer. We're going to create two security groups. We're going to create our S3 bucket and upload a sample code package. We're going to create custom IAM roles that provide custom policies to give access to what our EC2 will need. We're going to create an auto scaling group with Lifecycle Hooks. We're going to create a launch configuration and provide custom bootstrapped user data scripts. We're going to create an application load balancer. And then we're going to show how to do a deployment that will result in no downtime. Okay, so before we begin, I wanted to point out that in GitHub we have a repo. I'm posting out the code for these videos in this repo, and I'll put the links in the description as well. So download these files. We will be using these files as we go through the process. All right, so let's grab our list again. And our first item is going to be to create our VPC using the VPC Wizard and to create our second subnet. All right, so come over here and let's search for VPC. Now, if you're not familiar, VPC is a virtual private cloud, and this allows us to create essentially our own private network in the cloud. So the resources that we create in our network are isolated from the rest of our other resources in our AWS account. So we are going to click here with the Start VPC Wizard, and we're going to use the VPC with single public subnet. Now we're creating one with a public subnet, and actually two public subnets and no private subnets because we're hosting just a simple web server, but we could have created private subnets and we could have put our web servers or our application servers or whatever else we may need in the private subnets. So public subnets permit internet access to instances, and private subnets allow for zones that you can have resources in, but you cannot get internet traffic into them without something like a NAT gateway or a NAT instance, which is outside of the scope of this video. So we're going to use this, and we're going to select. We are going to give it the name AIRL for Amazon in real life, and we're going to call it VPC. 10.0.0.16 is fine. 10.0.0.24 will give us 251 addresses. That's perfectly fine. We'll call this public subnet 1. We have no preference for the availability zone. we're going to click create. And that's it. We have our VPC. Now we need to add our second subnet so that we will have it available for our application load balancer. So we're going to click over here into subnets, and we're going to say create subnet. We're going to call it public subnet 2. Let's make sure that we're spinning it up in our VPC. Now let's take a look. Our first one is in US East F, so let's put it in E so that they're not overlapping, because they cannot be overlapping in order to use them with our application load balancer. And we're going to give it a 10.0.1.0 so that we don't have an overlapping CIDR block /24. And we will create. Okay, we have our second subnet. Now, in order to make this a public subnet, we actually need to go in and ensure that our route table has an entry for our internet gateway. So if we look at our other one, and let's say ARL, these are our two subnets, and if we look at the one that the wizard created, we see down here the IGW, or the internet gateway. This route table has a route to the internet gateway, but the one that we just created does not. So we're going to go in here, and we're actually going to use the same route table as the other subnet. And we're going to save that. Great. So we can now on our list check off create a VPC and create a second subnet. That is now done. The next step is that we're going to create a security group for the ALB and a security group for the instances. So we're going to come over here into subnets, security groups, and we're going to create a security group, and we're going to call it ARL ALB for our application load balancer. Provides access HTTP to the ALB. All right, so this is going to provide access for HTTP traffic to go to our ALB, and we're spinning it up in our custom VPC. And we're going to create that. We're going to then make a second one for our EC2 instances, AIRL EC2, and this is going to be HTTP traffic from the ALB. And this is going in our custom subnet. Okay, so we're creating our security groups, but they have no rules. So we need to go in and we need to add our traffic for these. So on our inbound traffic for our ALB, we need to ensure that it can accept all traffic, all HTTP traffic from anywhere, 0.0.0.0/0. That will give us traffic, HTTP traffic from anywhere that the ALB can accept. We're going to save that, and then we're going to go to the one for our EC2. We're going to edit that. Now there's two different things that we're going to want to add, and I'll add the second one here in a little bit, because there's actually two places that you can modify your security groups. One is in the VPC section and one is in the EC2 section. And the EC2 section has a nice little feature that we'll take a look at. So for now, we want to add an HTTP rule. And we want to allow traffic. So this is the security group of our ALB. So we're stating that the ALB traffic will be accepted by our EC2 instances. And that's what this rule is doing. Save. Okay. So we just created a security group for our ALB, and we're allowing traffic on port 80. We created a security group for our instances, and we're allowing traffic from the ALB security group. And we're going to go over to the EC2 section and add our SSH rule. Now we're adding SSH because we're creating a Linux instance for this, and because we don't want to open it up to the entire world, we are going to restrict it to just our IP. So here's our security group, inbound. Now if you see here, the menu is a little bit different. So I'm going to add a rule for SSH. And over here, there's a nice little drop down that you don't have in the VPC section that allows you to select a custom or anywhere, or handily enough, my IP. So now we've added SSH for just my IP. And I know that I'm blurring this out, but you should see your own IP address there if you use this. So great. We've got SSH for our IP only into that security group. Next step is we're going to create our S3 bucket, and we're going to upload a simple code package. So let's hop over to S3. Okay, and you see I have a couple sample buckets I was working with, but we're going to create a bucket, and we're going to call it, now keep in mind that you can only have lowercase in this, and it'll yell at you if you do anything wrong. AIRL-code packages. Okay, and we are going to create this bucket, and we're doing everything in east, so that's fine. And create. All right, and I'm going to create a folder in here for latest, because maybe we want to have our latest code package dropped in there, and another folder for archives. So I'm going to create this latest folder here, and that's where I'm going to upload my code package. So if you remember the code that we downloaded from GitHub, we had a folder called website in there, and deployment 1 and deployment 2. So we're going to pick the first deployment, and it's just a really simple HTML file. So you guys can upload down the road whatever you want to, but in the case of this scenario, we're just going to upload these really simple web pages. And what I'm going to do is I'm going to zip this. I'm going to compress that, and I'm going to zip it. And then I'm going to say here, and I'm going to upload my zip file. Great. My deployment package has now been loaded to my S3 bucket. So we now have our S3 bucket, and we have our simple code package. This would simulate the build system dropping our code package into S3 for us. Okay, so the next step is to create a custom role in IAM that will be used by our EC2 instances and will provide access to only our S3 bucket that we need for code packages. So this is important because this is the principle of least privilege. I don't need to give all access to all buckets for my EC2 instance. I just need access to the one that's holding our code packages. So I want to make sure that I restrict access on that instance to only what is required. So let's hop over to IAM, and we're going to write custom policies, and then we're going to attach those policies to a role. All right, so we're going to click over here in the policies section and say create policy. Now in the folder that you have from GitHub, you should see two different documents, two different JSON documents, one for complete lifecycle hooks and one for single bucket read-only JSON. So let's go ahead and open up those, and I have them opened up here. This is our policy that we're going to copy over to our policy. But if you look here, we have some values we need to replace. Now what this policy is doing is there's three different allow policies in this. This is going to let us list buckets for our specified bucket and list where that's at. It's going to allow us for our specified bucket to get read-only of objects. So we can't put new objects, we can't delete anything, we can only get what's currently there. And then this will allow us to list all the buckets in S3 so that we can find the correct one. But if you were to navigate to another one, you wouldn't have access. So let's go over and grab real quick our S3 bucket name. Come here, we're going to copy this right here, and then we're going to hop back over to IAM, and then policies. Let's actually come in here and let's replace these placeholder values with our bucket name. Make sure that you only replace what's between the curly brackets. Great. All right, we've replaced those, and now we're going to copy this, create our policy, and over here in the JSON file area, we're going to copy this policy in, and we're going to say review policy, and we're going to give it a name of AIRL policy read only single S3, and our description provides access to only the specify S3 bucket, and we're going to create that policy. Great, so we have our first policy, and we can check that off. Now we need to add another policy here as well for Lifecycle Hooks. Now Lifecycle Hooks are a feature of autoscaling that allows instances that get spun up or created by an autoscaling group to be suspended from health checks until the lifecycle has been triggered to complete. So the reason we're going to be using this is that when we bring up a instance through our autoscaling group, we'll have a Bootstrap script that will be installing things. Now, autoscaling groups have health checks on them, and these health checks start once the instance is initialized. However, with larger code packages, this could cause a problem because the time it takes for our instance to install and run through our script could be longer than our health check duration. So our health check would fail, and then the instance would be registered as unhealthy, and the autoscaler would terminate the instance and then try to recreate it. And so you would get stuck in this cycle of creation, failure, deletion, recreation. So a way to get around that is Lifecycle Hooks, and we will embed in our user data, and we'll get to this point, we'll embed in there a complete lifecycle hook. And once the hook has been completed, it will then start looking at our health checks and will run our instance once it's actually ready. But we need to make sure that our EC2 has permissions to complete that lifecycle hook, make that call. So that's what we're going to add now. So we're going to create a policy, and we're going to go back to our Visual Studio Code. And it's a real simple policy here, and we're just adding the autoscaling complete lifecycle action. So let's copy this. JSON, same thing we did before, except there's no values to replace. We're going to review this, and we're going to call it AIRL policy complete lifecycle hooks. Allow for the completion of autoscaling group lifecycle hooks, and we're going to create this policy. All right, great. So we have our two policies that we needed. We can check those off our list, and we need to create the role. So we created the policies, but we don't yet have the role that we're going to use in EC2. So we're going to come over here to roles, and we're going to create a role, and this will be used by EC2 and just standard EC2. And now we're going to attach our new policies, and an easy way to find these is customer managed policies, and this is our complete lifecycle hooks and read only from the single S3. We're going to attach both policies to our role. We're going to call this AIRL role read only with hooks, or read only S3 with hooks. And allow EC2 instances to access single S3 and complete ASG hooks. Create a role. Great, we have our role. Next, we're going to go in and create our auto scaling group. So let's hop over to the EC2 section. And come down here to auto scaling groups. And we're going to create an auto scaling group. Now the first thing we need to do, because auto scaling groups are created by launch configurations, or they're used in tandem with launch configurations, we're going to create our launch configuration. Now we're going to be using the Amazon Linux AMI, so go ahead and select that. We're going to use T2 micros. This is a really small site, and the T2 micros are free tier eligible. So we're going to use that. And here we're going to give our launch configuration a name, and it's called AIRL. We're going to call LC for launch configuration. Now we need to make sure that we add that role that we just created to this. This right here is what's going to be attached to the EC2 instances that we bring up. So this is what will give permissions to our Bootstrap script to allow it to read from S3 and to complete our lifecycle hook. Now we're going to click here into advanced details. Now we've talked about user data. This is where we're going to get our user data from, or this is where we're going to put our user data at. So if we look in that file that we got from GitHub, we'll see userdata.sh, and in this we have a bash script that is going to download our code package and install it on the instance. So let's take a look and let's read through this. We're going to get root access to make sure that we can complete everything we're doing. We have some script variables here that we're going to fill in for our bucket name, our lifecycle hook name, our auto scaling group name, and our region name. Then we're going to do a cool little trick here because we need the instance ID for our lifecycle hook, and you can see it down over here. That's one of the required parameters to complete our lifecycle hook. Well, there's this service hosted on instances in AWS, and if you do a curl on 169.254, 169.254, you can get metadata about that instance, and one of those attributes is the instance ID. So we can dynamically get the instance ID when the instance is created and assign it to a variable to use down the road. We're going to get updates for this instance, and then we're going to install the Apache web server. Once that is installed, we're going to go to the var www HTML folder, and this is where Apache will look for an index.html file. Then we're going to look and use the AWS CLI. This is a CLI command, and it's already pre-baked into instances hosted on AWS, or at least the Linux instance. And we're going to use the S3 services, and we're going to copy from S3 in this place, so our bucket name, which will be our AIRL code packages bucket, our latest folder, and the index.zip code package we dropped in there, and we're going to install that into our var www HTML folder. We're going to drop that index.zip. Then, since it's a zip file and we need an HTML file, it's a zip and we need an HTML file, we're going to unzip that file here, and we're going to drop it in our current directory. We will then remove the zip file, so all that was in, and let's take a look what's in there. Deployment, it's just that HTML file. We're going to remove the zip, and then we're going to start our web server. Once the web server is started, we're going to do the complete lifecycle action. So until this point, the auto scaling group will see this instance in a pending wait state. So it's waiting to perform health checks and to carry on with its process until we complete this lifecycle hook. Once we complete this, it tells the auto scaling group, hi, all the custom things are completed. You can go ahead and continue, because we're sending it a task of continue. You can either do continue or abandon. In this case, we want to continue. We're going to continue with this process. So let's fill out our variables. Right here, we know that we had our AIRL dash code packages, and we're just going to check that over there in S3 real quick to make sure that that's correct, and I'm pretty sure it is, but it's kind of a pain if you get it wrong. AIRL code packages. Okay. Let's bring back our lifecycle hook name. We haven't created our lifecycle hook yet, so we're going to need to remember this name. And we are going to give it a name, and I've typed it up over here so that I have it on hand. And we're going to give it a name of AIRL auto scaling group lifecycle hook web server launch. Then our auto scaling group. What's the name of our auto scaling group? We haven't created that yet, but it will be of name AIRL auto scaling group. And it requires the region. I actually had an issue with bringing this up before, that I wasn't specifying the region and it failed. So we're going to specify the region, and in this case we're using US East 1. All right, and that's it. We filled in our placeholders. The script will take it from there. So we're going to copy this into our user data section. And we can see in here our values. Great. Now we're going to assign a public IP. The reason for this is because if we need to SSH into our instance, we need to have a public IP in which to do that with. If you forget to, you can assign what's called an EIP or an elastic IP, and you can get access to your instances via that. But you cannot access from your home machine through your private IP. You would need to be local to that network. All right, so this looks good so far. We've got our role, we make sure that, we've got the name, we've got our script with its filled in values, and we have a public IP address. We're going to add storage. 8 gigs is perfectly fine for this. Our security group, we created this earlier. This is our security group for our EC2 instances. So let's select our AIRL EC2 and then review and create our launch config. Now we need a key pair. Key pairs are going to be the way in which we can access EC2 instances. So it's encryption, and you provide a PEM file that will give you your, I want to say it's your private key. It'll give you your key in order to log in. So it's your public here. You can see it up here actually. Your public and private key. This is how you access your instances. Since we don't have one, we're going to create a new key pair. And we're going to call this AIRL KP for key pair and download. Okay, we now have our key pair, and I'm going to drop my key pair in here in case I need to access through SSH this instance. And I'm going to show you guys how to do that just so you do know how. All right, create our launch config. So we've created our launch configuration, and now we're creating our auto scaling group with this launch configuration. So if you remember, we already assigned a name for our auto scaling group because we're using it in our user data, and that was the AIRL SG. For now, let's put 0 instances. So it's saying do not spin up any instances just yet. We're going to select our custom VPC, and then we're going to pick the 2 subnets that we created. These are our 2 public subnets. Advanced details, we're not going to change any of this right now. Next, we're going to go to configure scaling policies, and we're just going to leave that as what it is. We're not going to add any notifications, however you can. Tags, we're going to name it, give it a name, and then AIRL ASG for auto scaling group. Review, and that looks good. So create our auto scaling group. Great. We now have our auto scaling group and the launch configuration used to create it. So we can check off auto scaling group. We haven't done the lifecycle hooks yet, but we did do our launch config, and we provided our custom user data. So now we need to create our lifecycle hook. So over here in our auto scaling group, if you look on the tabs down here, you have details and activity history and instances, but you also on the far right have a tab for Lifecycle Hooks. We're going to click in there and we're going to create a Lifecycle Hook. Now if you remember, we already have a name for this that we wrote down. This is for the instance launch, so you can either do on launch or on terminate. In this case, we want to ensure that our Bootstrap script executes correctly and is finished executing before it checks the health checks. The default time is 3600 seconds or 1 hour. The default result is abandoned. So this is saying that after an hour, it will trigger the lifecycle hook to abandon and to terminate this instance instead of going forward. And our hope, this should be done in a few minutes, not an hour. And that's why we're triggering a complete to state that we want it to keep going, whereas this will say something happened, do not keep going. And this looks good, and we're going to create this. So now we've created the lifecycle hook for our auto scaling group. So any instance that is created through our auto scaling group will now trigger the lifecycle hooks on the auto scaling group. So let's come in here and we can check this off. Next, we need to create our application load balancer. So our load balancers are what we're going to use to distribute traffic across multiple EC2 instances. This is what's helping us to get our fault tolerance by routing traffic to multiple instances. And load balancers will like round robin, so it will hit different instances in our that are associated with it, and we'll see that here in a little bit. And then our auto scaling groups are the self-healing component. So if an instance fails its health checks, or there's any issues with it, it will terminate the instance and then bring up a new instance that should become healthy. So we're going to create our load balancer, and we're going to create an application load balancer. We're going to give it a name of AIRL, ALB for application load balancer. We want it to be looking on port 80 for traffic. We want to make sure that we create it in our VPC, and this is why we created 2 subnets, because it needs to be associated with 2 public subnets. So now we're going to configure our security settings, and we're not going to do anything with this, but we are going to give it its security group. So if you remember, we created a security group for this, and we're going to add the AIRL ALB security group that we created earlier. Configure routing. Okay, so in an ALB or an application load balancer, you have target groups, and these target groups are routing policies that you establish. So in this case, we're only going to have one, but you may have an instance with your application load balancer where you would have a couple different target groups, and you would state that all traffic from port 80 is going to go through a target group for our port 80 traffic, and it will be handled by a certain set of EC2 instances, or it may have a different health check. And then maybe we have one for 443 for HTTPS, and we may want to handle that differently. This is where we can configure these routing policies in our application load balancer. So in this case, we're only going to have one. We're going to call it AIRL, TG for target group. We're looking for HTTP traffic on port 80, and our target type is instances. These are EC2 instances that we're creating. And now we're going to create our health check. And this is this is a service that's going to ping on our EC2 instances to ensure that they are healthy. When the health checks pass, instances should come up in service in our application load balancers. Now, if they fail for any reason, they should be taken out of service. So the ALB is stating, I can't trust that you can handle the traffic I provide for you, so I'm going to take you out of the rotation. In this case, we're going to use index.html because that's our home page, and it's going to go in and it's going to say, hey, do I get a 200 OK from index.html, which it should. Now we can configure advanced checks, a healthy threshold of 5 and an unhealthy of 2. For simplicity's sake, we're just going to do 2 intervals of successes, we're going to say that's okay. And if there's 2 intervals, consecutive intervals of failures, then it's going to say that the health check failed. All right, we're going to now register our targets. We currently have no instances because we need to associate our auto-scaling group with our application load balancer, and we'll do that in a minute. And then we're going to review, and we're going to create. Close. Okay, now we need to go. We have our application load balancer. We need to associate our auto-scaling group with it. So we're going to go into auto-scaling, and here in our details, there's a section for target groups. Now, if you're using a ELB, the classic load balancer, you would put it in here. But since we're using target groups, we're going to register our target group, which was our AIRLTG, to our auto-scaling group. And this is saying that instances that come up through this auto-scaling group should be registered into our application load balancer to receive traffic. All right. Now let's take a look at our checklist. We've created our application load balancer. We've registered our auto-scaling group to our load balancer. And now we need to scale up our auto-scaling group. So we're going to scale it up to 2 instances. So if you see here, you have a desired, a min, and a max. This is what's going to control the count of instances that will be created by our auto-scaling group. In this case, we're going to say 2 and 2 and 2. This is stating that I want exactly 2 instances in our auto-scaling group. Save. All right. So we see here that there are currently 0 instances and the demand is 2. We're going to look here in this instances tab. Now we give it a few minutes and let's take a look. And now we can see that there are 2 instances being created by our auto-scaling group to be registered into our application load balancer. So let's take a look over here. We'll close that. And we're going to look in our instances. Close that. We can see our 2 instances coming up. Now they're initializing right now, but these are the instances that have been created by the auto-scaling group. Now, remember what we talked about the lifecycle hooks? These instances are currently in a pending wait state. So this is the lifecycle hook has been triggered for these instances, stating I'm waiting for this lifecycle hook to trigger that it's complete and that I can continue. And that will be done after our user data script has been run on the EC2 instances. So they will remain in pending wait until after the instances come up, they get launched correctly, and then the user data script executes correctly and it triggers the complete lifecycle hook in the user data. We will then see it come up into in service. So this will take a minute to come up. Okay, we see our instances here. They are in service. This means that the user data scripts should have executed properly on the EC2 instances, and they should now be able to be live in our load balancer. So let's look at our target group and let's see if these instances are indeed accepting traffic. All right, so if we look in our target group, we see our 2 instances and they both say healthy, which means our our application load balancer is sending traffic to these instances. So let's test our website. Let's come over here to our application load balancer, and we're going to come down here, and there's a DNS name right here. If we grab this, now this is something that we could associate with a Route 53 or a DNS entry that we purchased, but for the scope of this video, I'm not doing that. then let's go to that DNS and let's see if we get our web page. Great. That's our simple web page. Doesn't look like much, but keep in mind, whatever code packages you install will come up here. So do with it what you want. But we now have traffic running through our load balancer. So let's take a look at our checklist. So we've scaled up to 2. Now let's modify that code package. And let's see if we can do our update to our instances. Now we don't want any downtime with our instances. So how are we going to deploy? We're going to change our code package, but how are we going to deploy to our instances but have 0 downtime? Well, let's first come in here and let's change our code package. Let's go to S3. Let's go to our code packages, latest. All right, if we look, sorry, wrong folder. If we look in our website and deployment 2, there's another index.html, and we're going to just zip this up. Great. And then we're going to upload. All right, this has one more line in it, and it just says deployment 2 in it. So I'm expecting to see this plus one other line below it that says deployment 2. All right, we have our new code package, but we need to know how to deploy this without bringing down the current site. Nobody wants downtime. Well, we're going to do that with our auto scaling group. So let's go to our auto scaling group. We currently have 2 instances running. However, what happens if we scale this up to 4? All right, so we're saying let's have 4 instances of just the 2 that are currently serving traffic. Now, since we are using user data scripts when we launch new instances, the user data will now be grabbing that new code package. So the 2 new instances that we create should have the new code package being pulled during the launch of them, so that we'll have 2 instances with the new code package and 2 servicing the old. So let's wait. We're going to wait for our instances to come up. Let's take a look here. Cool. Now we see that we have 2 instances that are pending. So we're going to wait for these 2 instances to come live and come into service. So I'm expecting to see pending wait here in a minute. And if we look here, we're not losing any traffic. It's still hosting our site. We have no downtime, no latency, and we're just bringing up 2 new servers alongside the 2 that are currently hosting our traffic. Okay, so they're in their pending wait state, which means that they're awaiting the Bootstrap script to complete the lifecycle hook. They're going to be going out to S3. We're going to be grabbing that new code package. We're going to be downloading it, unzipping it, getting rid of the zip, completing the lifecycle hook. So in a minute, when these come live and they're being serviced traffic through the ALB, I would expect to see, as we refresh the page, sometimes the page will have this, and sometimes it will say deployment 2. We have 1 of them in service. We're waiting on the 4th one. We might even see it now. We'll see. See, we're still, okay, there we go. So as you can see, I've been clicking refresh pretty consistently. We've had 0 downtime, and now some of our instances are servicing the new code package. Let's see if this one's live. Great, we have all 4 of them in service now. And we can see that we're hitting the different instances. So we don't want to leave it this way though. And let's look at our target group as well, just for sanity's sake. Make sure that we see all 4 of them live, which we already see because we can see it through the URL, but all 4 of those instances are healthy. Now, we're going to go back to our auto-scaling group. And because of this little thing called termination policy, it's going to remove the instances that are the oldest. So let's scale this back down to 2. What this will do is, now that we have all 4 servicing traffic, and we're going to say 2, it's going to terminate the 2 oldest instances, removing the instances that contain the old code package. So here in a minute, we should see that it says terminating on 2 of these. And this might take a minute. We can look here, we're still getting traffic, no downtime. Okay, now we see 2 of them are terminating. And we will look at our target group. And in our target group, see it says draining. So it is now no longer, our ALB is no longer sending traffic to our old instances. So now we should only see deployment 2 anytime that we refresh the page. So we have now just deployed, without any downtime, our new code package. So let's take a look at our checklist. So we modified, we deployed our new code package using a rolling update without any interruption. And it's tearing down those instances. Now, for sanity's sake, I want to show you guys, if you aren't familiar already, how to SSH into these instances. So let's take a look, and let's make sure that we're grabbing one that's not going to be terminated, otherwise it'll kill our connection. Alright, so let's come here and let's go to this one. I want to SSH into this instance. So I'm going to come here and I'm going to see and I'm going to cd bootstrapped deployments, and I am going to list what's in here, and we see our key pair in here. Nice little feature is if we say connect, Amazon gives us this example SSH key. And we're going to go in, we're going to paste this in here, and because my key pair is in the same folder, I can say, are we sure we want to connect? Yes. And now I have SSH'd into this instance. So we'll go in here, let's change our directory to var www html and list this, and we see our index.html. So how about we do index, and we can see in here this is our HTML that is on this instance, and maybe we just add another one here for h3 align equals center, and changed here h3. Alright, and let's close that, and we want to save. Oh, x no sudo index.html close, yes. All right, and then nano, let's make sure our change took. All right, we see that, close. Let's go over to our browser. We should see that round robin into rotation. And there we go. Let's make sure that our auto scaling group terminated those instances. It's still in the process, but I'm not going to hold you guys here while it does that. Let's take a look at our checklist. All right, we have in this completed our scenario. We were able to create a simple web page with infrastructure that is fault tolerant, self-healing, and will permit our developers to easily deploy code packages from highly durable and fault tolerant centralized storage. So we used a VPC to isolate our resources. We're hosting on EC2 instances. We're using user data to create Bootstrap scripts, and we're downloading our code packages and installing them from S3 and installing them on our instances. And we're using Lifecycle Hooks in order to ensure that those instances complete the Bootstrap script before they start to check the health checks. Anyways, I hope this was helpful for you, and I appreciate you taking a look at this video. Thanks.